Hey guys, what's up?
Nice, sir.
क्या किया तूने वीकेंड पे?
Yeah, hi everyone.
Hey, hi, buddy.
Hello.
Hey, hi, everyone. Okay, so what we have done, guys, we have covered the switching part. If you guys remember that, right? So in a switching, basically what we have covered, we have seen that how to, hey, hi, Karaz. So how to connect with the multiple PCs, right? So how to connect with the multiple end user, we can say that. So we have a PC number one and we have a switch over there. Take example. And then we have another PC, we have another PCs, right? And we have another PCs, right? So basically, what we have seen that how you can connect the communication between the PC1, PC2, PC3, and PC4, right? So you can have a hub as well, you can have a bridge, you can have a switch. We have covered the VLAN and everything, right? VLANs, spanning tree protocol, DSCP, third channel, right? But the problem with the switch is what? I'm not saying that's the problem. This is the feature of the switch. The switch only provide the LAN communication. Switch only provide the LAN communication. LAN communication in the sense of what? Whatever the users are present in the same broadcast domain, right? Whatever the users are present in the same broadcast domain, you can provide the communication with the help of switch. So for example, you have a 192.168.1.0/24. So whatever the users are present in this domain, for example, we have some users over there. I can provide the communication with the help of switch. So take example, we have another broadcast domain now, right? A logical domain. We have this is the network we have 2.0/24. So if you want to provide the communication between the this two domain, right? So we need a new person. That new person name is called as what? Router. That new person name is called as what? Router. So with the help of router, right? With the help of router, you can provide the communication between the two broadcast domain. So today we are going to start the part of the router. So basically, let me explain you the few theory words. I know you guys know about the router. So router is a layer 3 device, or we can call as it's a hardware box, right? Depend on the companies, they have launched the different hardware. For example, Cisco has their own router, Juniper has their own router. Juniper has their own router. One minute, guys. Hello. So router is a layer 3 device. I'm so sorry, guys. So router is a layer 3 device. Many company has given the router. So, the Juniper, we have a router, Cisco, we have a router, Huawei, we have a router, HP, we have a router, right? Multiple vendors have a router, and each vendor has a different series of router. So if I talk about in Cisco, right? We have a Cisco iOS router, right? So iOS is a basically operating system, right? iOS is a basically operating system. In this iOS router, we have a multiple series of there. Like for example, what we call. So we have a Windows, right? So Windows is what? It's like an operating system. So Windows can be supported by the HP. They have a Dell, right? And you can go with the Lenovo as well, right? Same thing. iOS is like a Windows, right? It's an operating system, the router, and router can have a different flavor as well. Same way, we have another type of router in another type of operating system. Cisco is what? We have a Cisco iOS XE. So this is Cisco iOS XE router, right? So again, this is the operating system, and we have a different series of the router for the iOS XE. We have a Cisco XR router. XR also have a different. For example, we have a ASR 9000 router for the XR, right? Apart from this thing, right, we have a different vendors of the we have a different series of the router in the Cisco as well. So router is basically what? It's a layer 3 device, or it's a pure hardware box. It provide the connectivity between two broadcast domain. So with the help of router, you can provide the communication between the two broadcast domain. If you guys remember that, we have seen the communication between the two VLANs, right? For example, we have a switch 1 over there, and this is a user part of the VLAN number 10, and this is the user of the part of the VLAN number 20, right? So with the help of router, what we have seen that you can provide the communication between this guy. So between the VLAN number 10 to the VLAN number 20, you can provide the communication with the help of router. That's called the inter-VLAN routing. So router, the main purpose of the router is what? It's going to provide the connectivity between the two broadcast domain, right? And at the same time, it maintain routing table. Like a MAC address table on the switch, we have a MAC address table. Router has a routing table. Routing table, it's like a phone book of your phone. So based on the routing table, right? Based on the routing table, router forward the packet, right? So whenever router receive the packet, for example, understand this concept. So this is the router 1, and router maintains the routing table. So routing, for example, router 2 we have over there. So this is the 0/0, this is the 0/0. And this guy has a 2.2.2.2. subnet over there. Understand this concept, right? So we have a subnet between this guy's 110.1.12.0/24. So basically what happened, this router has a 10.1.12.0/24 is configured, right? So this is my routing table that router is going to maintain. C means what? C means going to say that it's a connected. This route is connected to the router number 1. So whenever the router receives the packet, so for example, if the router receives the packet that has a source, could be anything, doesn't matter, right? And destination will be what? 10.1.12.1. So what he will do that whenever the router receives the packet, it perform the lookup in the routing table. And based on the routing table, he will forward the packet to the next router, right? So he will forward the packet to the next router because the 12.2 is connected to the router number 2 and 12.1 is connected to the router number 1. So he will forward the packet to the router number 2. If the packet is coming for the 12.1, then router will receive the packet and send the packet to this particular interface. He will not forward the packet to the next router. It seems like that it's like a phone book. If you have my number in your phone, you can make a call. If you have my number in your phone, you can make a call. If you don't have a number, you cannot make a call. Same behavior. If the router has a route, then he can forward the packet. If the router doesn't have a route, then he cannot forward the packet. Another example, understand, source could be anything again. Destination will be what? I have a 8.8.8.8.8. So this is the source and this destination. So whenever this packet comes to router, what router will do that? Router will look for the destination. So do I have a 8.8.8 in my routing table? No, I don't have. So in this case, the packet will be dropped. So whenever the router receives the packet, it performs destination lookup in routing table. If the route is present in routing table, then router forward the packet. Otherwise, packet will be dropped. Simple logic. If you have my number, you can make a call. If you don't have a number, you cannot make a call. So this is the basic funda about the router. And one more thing, each router interface represent a separate broadcast domain and collision domain. And router break the broadcast domain. Right? So for example, this is the one router we have, router number 1. So router, this interface have a separate broadcast domain and separate collision domain. This router interface have a separate broadcast domain and separate collision domain. This router interface has a separate broadcast domain and separate collision domain. This router interface has a separate broadcast domain and separate collision domain. Now, this is the basic part of the router. Now, what router is maintained over there? Router main thing is the router it's maintain the routing table. In routing table, what information is present? In routing table, basically your network is present. Your IP address is not present. On your router, in the routing table, your network is present. Your network you can call as a prefix, right? You can call as a route as well. So in the routing table, only the route is present, network is present, and prefix is present. Now, how does the router provide the connectivity? Take example. What I can do that. I have a lab with me. So hold on. A very basic lab I have. Okay, before I'm gonna show that this thing, right? Let me show you something else. That how does a router maintain the routing table? So let me pause this guy. I really don't need this one. And I have a open project routing table. What prefix I missed? That prefix is nothing but just a name of the route. So 1.0.0.0 is called as a route. You can call as a prefix as well. Just a name. So different routing protocol has given the name.
Oh, thank you.
Most welcome. So let's take example. I have a 72 series of the router. This is the name of the router. And I'll just have a two router. That's fine right now with me. Okay. And what I can do that. Just try to understand the first of all, how does a router maintain the routing table? That's a very important part. And by default on the router side, IP routing keyword is enabled, right? So whenever you give the IP address on the interface, right? Whenever you give the IP address on the interface, automatically what happened? A router will find the subnet for this guy. And once the router will find the subnet, or we can say the route for this guy, then they will install the route in the routing table. So they will not install the IP address in the routing table. They only install the route in the routing table. So take example, we have our two routers, router 1 and router 2, right? So right now we have a one broadcast domain. And router cannot forward the broadcast packet, right? Router never forward the broadcast packet. So once the router will receive the broadcast packet on the one interface, it will never forward the another interface. So for example, we have router number 1, we have router number 2, and router number 3. So 0/0, we have 0/0, and this 0/1, and then 0/0. So take example, if I'm sending the broadcast packet from the router number 1, so this broadcast packet will receive on this interface. As we know that a router break the broadcast domain, it will never forward this packet to the another broadcast domain. So router break the broadcast domain by default. So they will never forward the packet to the another broadcast domain. So the packet will be received on this interface. That's all. So have a look on the router number 1. So if you see right now, it seems like a pure phone. So when you purchase the new mobile, right? When you purchase the new phone, and what you have in the phone, nothing, right? Until or unless you're not gonna put the number over there. Same thing if you see on the router right now, I have a show IP interface brief command. It will show you whatever the IP addresses is configured on the interface. I don't have any IPs configured, right? So the first command that I have over here, show IP interface brief, this command will show you the IP address on the interface and many more things, guys. I cannot write each and everything because if I'm gonna write each and everything like a status and everything, it will like I'm gonna write the book for this one. So this math will be never over in the next 3 months, right? So the basic part. So show IP interface, you can see that I don't have any IP address configured over there. Even if you check the routing table right now, show IP route, this command will show you the routing table, right? And I don't have any routes in my routing table. It seems like a phone, right? So when you purchase the phone, you have a phone book, but in that phone book, you don't have any numbers over there. right? You don't have any numbers over there. So what I can do that, I'll just go to interface. And before I'm going to do that, I'll just say the debug IP routing, right? And what you can find that, first of all, I'll show you the by default IP routing command is enabled, right? By default, the IP routing command is enabled. And because of that reason, router have a routing table. So this command is hidden command, and which is by default enabled on the router side. So if you check on the router number 1 and 2 as well. So if I'm going to show you the no IP routing, if I'm going to disable it, understand the concept. What happened? I lose my routing behavior. So IP root, what is saying that, hey, you don't have any routing table right now. So what he's saying, the box changed from the router to the host mode. It means that now this router is behaved like a what? It's PC. So once I'm going to enable this command IP routing, then what happened? Now this is behave like a routing table. So now the box had changed from the host mode to the router mode. Now I have a routing table. So if I'm going to put the same command, right, do so IP root, right, I have a routing table. So this command is mandatory. So if you're going to convert the router as a PC, so you can disable the no IP routing. If you disable the no IP routing, then you will lose the routing table and they will ask you configure the default gateway. So what I can do that, understand the concept. If I give the interface 0/0, once I put the IP address on this interface, right, 12.1, then what happened? Automatically what happened, they will find the subnet for this guy and they will install those route in the routing table. Can you see that? This Artemis routing table, I'm adding this route, /24 is a subnet mask. Via 0.0.0 means it's a next hop. Hold on, you will understand what is the meaning of next hop. So when you see the 0.0.0, the 0.0 means what? It's gonna represent that it's a directly connected next hop. You will understand the meaning of next hop. Hold on, don't worry. Just write those things directly connected, because I cannot write each and everything in the notepad, right? So whatever the important commands are there, verification command, I'll help you to write over there, but not each and everything, right? So it's the meaning of directly connected. It's a very important interview questions. So when you go for the higher level, right? So they will give you the debug output, and based on the debug output, you need to identify. And if you see that, I'm adding this interface in my routing table as well. What happened if I'm going to remove the IP address from the router now? If you see that, I do have a IP address on the router right now. You see that? And because of that reason, the router maintained the routing table. If you see do so IP root, I have a route. C means connected router. C means connected. But what happened if I'm gonna remove the IP address? So I said the no IP address because I'm under the interface right now. I just say the no IP address from the interface. Then what happened? IP will be removed from the interface, and I don't have any route in my routing table. So delete the route will be deleted from the routing table now. So if you check the do so IP root, it's gone. What does L mean? I'm coming to the point, Boozer. Hold on. So if you see again back, so if you don't see, I don't have any routes. Again, what I can do that, I'll just put the IP now. And now you can see that I'm adding the same information in packet. So as soon as you put the IP address on the router, what happened in the background, they put the route in the routing table. And now you can see that I have a route in my routing table. So if I'm going to remove the IP address from the router, it will be gone. Again, if you see that, if I say the no IP routing means what? So basically IP routing keyword is going to create the routing table, right? And if I say the no IP routing, then what happened? It will delete the routing table. So whatever the router in the routing table, they all will gone. So if you see right now, I have a routing table right now. So if I say the no IP routing table will be no more. So if I put the command so IP root, it's not there. So these are the basic part. Again, this is the first and important command for the router, because of that command, the router behaves like a router. Otherwise, they will change as a host mode. right? This next question the user has asked, what is the meaning of L over there? L means it's a local route, right? So this one is only comes in the picture. This local route only comes in the picture when you have a higher version. If you go to the lower version, you will not see the L route over there. L means simply what IP address you have configured on this particular interface. That's a local one.
Thank you.
Most welcome. So this is how same thing you can go on the router number 2. So router number 2, I'm not going to enable the any kind of debug over there. Let me do that IP routing. So once I'm going to back the IP routing command, once I'm going to again put the IP routing command, then what happened? Your routing table comes in the picture. And all the route will be appear now. Same thing, what I can do that, I just need to go on the router number 2 and I'll simply configure this guy. Hey, listen, I like to configure the IP address to you as well. And I'm not going to do that like, any debug command over there. So in the background, you can see that you will not see anything. By default, the router interface is by default down. By default, it's down. Then that's why you need to put the no shutdown command over there. In that switch, if you remember that I explained you this thing, right? On the switch, you don't need to do this thing because by default, the switch interface is up, but the router interface is down. So you need to manually put this command, no shutdown command over there to just up this interface. And now you can see that, do I see any kind of debug over there? Because I haven't enabled the debug. But what happened, they will find the subnet for this guy, or we can say the prefix for this guy, or we can say the route for this guy, and they will put in the routing table. If I'm going to say that no IP routing, it will gone. If I say that again IP routing, it will come up. I hope you understand the meaning of IP routing. So IP routing command. This command enable unicast routing, unicast IPv4 routing and router. Next is what? Now you can send the traffic, you're ping it. Okay. Interface 0/0 IP address because I have configured the wrong IP address on the router interface. I think it's 12.1. So I've configured the 12.1 192 range, and over here I configure the 10 dot range. So let me correct it. So what happened if I'm going to give the correct IP address on the interface? So they will remove the previous IP and they will add the new IP. And now if you're going to send the traffic, for example, I'm going to send the ping 10.1.12.2 from the router 1 to router 2, I can easily send the packet. So the first packet, you can see that it's dropped just because of what? ARP, right? And remaining, I have sent the 5 packets totally. So in a unicast, so whenever you answer the ping, what ping 10.1.12.2, in that case, what happened? The source IP always will be a exit interface IP. Your source IP always will be a what? Exit interface IP. So when I say the ping from the router number 1, so the packet should be like this way. So where you have a 10.1.12.1, that will be the source IP address. 10.1.12.2 will be the destination IP address. And the router 1 will forward the packet to the router number 2. So by default, when you say the ping, the unicast packet, by default, it will send the 5 packets. The size of each packet is 100 byte. And I'm sending the ICMP equal request packet to the 12.2. And the timeout is 2 seconds. Timeout means what? If I'm sending the one request packet to you, I should receive the reply. If I'm not receiving the reply, I will wait for the 2 seconds and I will send the next ICMP packet. If I'm not getting the reply, then again, I will wait for the 2 seconds. I will send the next ICMP packet. And 4th packet I have sent, for example, I got the reply. 5th packet I sent, I got the reply. So it means that what happened? 60% the packet will be dropped. 3 packets has dropped, 2 packet has a successful. So this is just gonna tell you the delay. So if you can see the round trip means what? Round trip means something like that. I mean, I have sent the packet and I got the reply from the router number 2 to router number 1. Because of course, when I'm gonna send the packet, this will be the packet executor. But when the router 2 is going to give the reply to router 1, so in that case, what happened? 10.1.12.2 will be the source and 10.1.12.1 will be the destination. Guys, source will become the destination and destination will become the source. This is the packet generated by the router number 2. This is the packet generated by the router number. So this is the ICMP echo request packet. And this is the ICMP echo reply packet. So the delay, you can see that over there. It's a round trip means what? The meaning of round trip means if I'm sending you something, I'm getting the reply. That's a delay we have. So minimum delay is over, you can see the 36, maximum is the 56, and the 49 is the average delay. So it's a millisecond. So in a 1 second, if you remember that, we have a 1000 millisecond. So the average delay, if I talk about the packet between the router 1 to router 2, it's a 49 millisecond. It's not a second. Guys, anyone has any question in the basic part of the router?
No, sir.
So that's a basic one. But you know, the problem comes in the picture when you have a multiple routers. So right now from the router 1 to router 2, I can ping in because they are the part of the same broadcast domain. I can send the traffic. There is no issue, right? If I'm going to send the traffic, I send the repeat, right? 100. I don't have any issue. From the router 1 to router 2, I can send the traffic. But the problem comes in the picture when you have a multiple route. So for example,
Yes.
the project like 1 minute, guys. I did the recording for the YouTube one, and I have saved the project for the YouTube starting. Yeah, it's great. So you can see that. Understand this topology first of all. Understand. So what I did, or I think so. Let me configure for you guys new topology because it's totally a new classes for you. So I don't want to make any kind of problem. So better to configure the new for you guys. So instead of take example, I take the some PC right now. So I have a PC1 in the one location. It's a different location. So maybe it's in India, it's in Dubai, and we have another in the maybe in the UK. So we have 3 different LAN. One LAN is in the India, right? Another LAN in the UK, and another is maybe USA. So 3 LAN network we have, 3 PCs, right? 3 users. Of course, we can have a multiple. So if I'm going to connect to the PC to the switch, sorry, PC to the another PC, we need to take a help of switch over there. So I don't have any other PC. I just gonna connect the switch over there. So between the PC1 to the PC switch, then we have another switch we have, and we have another switch 2960. Right? So I'll provide the connectivity between this guy to this guy. This guy to this guy. All done. All good? Yeah. Next part is what? So we have a network over here. Try to understand. We have a 10.1. Okay, let's do the network of the LAN is 191.168.1.0/24. The IP address of this guy is 192.168.1.1. right? The IP address of this guy is 192.168.2.1. Of course, in the difference environment we have, and here we have a 2.0/24. Same thing, we have a 3.0/24 and 3.1. We have the IP address, right? All good. Now we have a router over there, because if you want to provide the communication between this subnet to this subnet, what happened? We need to take a layer 3 device, and that layer 3 device is a router. Because I cannot provide the communication between here to here like this way. I cannot do that. I cannot make a trunk and provide the communication. It's not possible. So I need to take a help of what? A router. So we have a router over here. Take an example. We have a 28 router 1, router 2 I have, and router 3 I have. I'll just use the cable to connect this guy. Then we have a this one and to this one. I knew that. So I don't have a ports over there to connect over there. So to add a port in the Cisco packet tracer, what you can do that? You simply click on the router, expand this guy, and just turn off the router. You can see that over here. Just click on this guy, just turn off. So now it's see that it's a black over there. Otherwise, it's a green over there. And then you can take a one FE2. So I just need a one cable of the fast Ethernet. So you can see that description is over here, right? It's a one fast Ethernet cable interface. So I can put this guy into the module. Okay, and now the turn on this guy. Same thing, now I can connect the cable. All done. Same thing, I think so I need on this one as well, or maybe not. I have one port. Yeah, that's great. So all good. So you can see that I have a router 1, router 2, and router 3. So why do we need a router? To provide the communication between this subnet to this subnet and this subnet. Because to provide the communication in the different broadcast domain, we need a layer 3 device, and that layer 3 device could be the layer 3 switch or layer 3 router as well. Simple topology we are doing right now. Once we have done, then we'll go to the advanced level. So now we have a network. We are going to use 10.1.12.0/24. Between the router 1 and router 2, we are going to use the 12. And between router 2 and router 3, I'm going to use the 23.0/24. All done. And the IP address that I'm going to use between router 1, over here it's a 10.1.12.1. This interface, I'm going to use the IP address 10.1.12.1 because each interface of the router, right? Each interface of the router has IP address. Okay, so same thing, I'm going to give the IP address on this particular interface. So 10.1.23.2, 10.1.23.3 on this particular interface. And on this particular, of course, we have a 0/0 also over here. So I'm going to use the IP address of the 1.100. So of course, this is the one broadcast domain I have. So in this broadcast domain, I'm going to use the IP address of this subnet. Same thing, we have a one broadcast domain over here. So I'm going to use the IP address of this subnet, and same thing over here. So the IP I'm going to use over here is the 3.2.100, and over here it's going to use the 3.100. All done, right? So that's the basic part that we have done. Now what I can do that, let's start the configuration. So on the PC one, we'll give the IP address first. So I'll give the IP address is 191.1.1. Come on. /24 is my subnet mask. Then we need to give the default gateway, because if you want to send the traffic from the one broadcast domain to the another broadcast domain, right? If you want to send the traffic from the one broadcast domain to the another broadcast domain, you must need to have the default gateway. Without default gateway, you cannot go beyond the broadcast domain. So you must have a default gateway information. Default gateway is like a gate of this network. So for this network, who will be the gate? For this network, this interface will be the gate. The IP address of this particular interface will be the gate. So I'll give the IP address of this guy as 100, and this guy as well.
Same message, but ignore put temporary.
Guys, please be on mute. 2.100, because for this PC, this IP will be the default IP, and same thing this PC. This will be the default IP. That's done, right? Now what I can do that basic part, just open this router, CLI, just go in the command line interface. See the no, because I don't want to go in the dialog configuration box. Enable same command like that, right? That you guys have done in the switching as well. Config terminal. Let's first define the host name. And what I can do that first of all on this particular interface, right? I'll give the IP address 0/0. Then we'll go for the 0/1 as well. So on the 0/0 interface, what I can do that I'll say that IP address will be what? 1.100/24. By default, the layer 3 interface is down. I need to say the no shutdown. On the 0/1 interface, I can call this guy the 10.1.12.1/24 and no shutdown. By default, router interface is down. You need to turn on the interface. So I can put the same configuration on the notepad so that you can follow this notepad to do this lab, right? Just need to go in the config terminal, right? And interface 0/0, I can call this guys out. All done. Same thing on the 0/1. We have a 10.1.12.2/12.1/24 and no shutdown. Then we have router number 2 now. On the router 2 as well, you can see that our 3 interface, right? Config terminal. Host name will be router 2, interface 0/0. IP address will be 10.1.12.2. So on this particular interface, I just give the IP address to router 2, right? Now we need to give the 23.2 on 0/1. And here we go. And then last 1/0, that's my LAN information. 2.100. Okay. How to remove the IP address from the router? A basic command, interface, under the interface, you just put the no IP address, right? We have seen that in the DNS3. And you cannot have a, like, you can have a 2 IP address on the one interface, right? This is the one of the interesting question on the interview. So on a one interface, you can put the 2 IP address. But it could not be the 2 primary IP address. So one you can put the primary IP address, one you can put the secondary IP address. But you cannot put the primary and primary same time. It will be override. So you can have a primary and secondary. Same thing on the router 3 now. On the router 3 also we need to give the IP address. Okay, maybe let's do the copy and paste this configuration on the router number 2 right now. So CLI. I don't want to go in the dialog configuration box, enable, and I'll just copy and paste it. You can see that? All done. Host name, interface, no shutdown. Just last 123.2, no shutdown. And 1/0, no shutdown. All done. So even if you want to verify the things, right, you can easily verify it. Do show IP root. I have a routing table. It's 0/23.0 is not there. The reason is that we need to turn on this interface. So if you see, we don't have a local over there. Can you see the local over there? We don't have. We just have a connected. The reason is that my Cisco packet tracer is the older one. So in the older version, you will not see the local keywords, the local dot that I have just shown you in the GNS3, because the GNS3 data I'm using right now, you can see that the do show version include iOS. It's a new iOS, right? So in the new iOS, you can find the local, but in the older one, you cannot find it. Now the same thing, what I can do that I just need to configure the router 3 as well. So router 3 also have a IP configuration. On the router 3, what I can do that? I'll say the config terminal host name will be what? R3. Interface 0/0, you can see that. It's a 23.3. This interface is a 23.3. And here we go. Interface 0/1, I have a 10 or okay, 192.168.3.100. If you see one thing, guys, I haven't done any kind of configuration on the switch side, because on the switch, I'm assuming that all they are part of the same VLAN, that is the VLAN number 1. I haven't configured anything. If you want, you can configure it. Of course, if you want to make the different VLAN member, you can do that. We'll do the lab of this thing as well. Don't worry about that. But right now, my agenda is make a same VLAN number 1, simple lab. So copy and paste this guy again. CLI. No, come on, no. Enable config terminal. Okay, let's copy and paste it. All done. So you can see that my all IPs present right now. Host R3 interface 0/1. So what happened if I'm going to reload this router? What happened if I'm going to reload this router, right? So take example, let me go to physical and off this router. And again on this router now. Hold on, the booting process is going on.
Question while it's booting. Earlier, when you said the switch is by default in VLAN 1, I believe what you meant to say is they are in the VLAN. Each individual switch is part of the VLAN 1 within its own network. Not
Right.
all the 3
On the
switches.
Cisco
Okay, just
device.
wanted to make sure.
Yeah, on the Cisco device.
Okay, yeah, not all 3 switches are in the same VLAN 1, but their own VLAN 1s.
They
Okay.
have own VLAN 1. So you can see
Okay,
that once
thank
I turn on this router now, turn off and turn on, reload this router, what happened? My all the configuration has gone. Right? So you need to do the again configuration. So if you don't want to do the configuration should be gone, then better to do save this configuration. So there is a 2 ways to save this configuration. Now again, I have put the IP address. You can see that. So there's a 2 ways to configure save the IP address. What you can do that? Simply I can put the copy. This is the, if you can see the configuration that I have right now. I put the command show running config. This command will show you the right. So this command will show you the entire router configuration. Whatever the configuration you have done in the router side, whatever the routing protocol, SSH, telnet, NTP protocol, SNMP, whatever the configuration you have done, everything it will show you on the running config. So you can see that I have done the host name. So running config, building the configuration. So the total size of this configuration, the 576 byte, each configuration requires some space, guys. These are the pre-config something, live with those things. Host name, I have R3. And by default, the span TPVST is enabled, right? And interface, how those things are enabled also is router side. I have no idea, man. On the router, it should be disabled. So we cannot do anything. It's a Cisco packet man. So we have interface 0/0 and we have a 0/1, right? And this is the SPI, leave it. That's not a big deal. It's not a VLAN, it's a SPI. And that's fine. So there we have all configuration. So again, if I'm going to reload this router, all will be gone. So better to do one thing. I can save my configuration, copy running config to the startup config. Yes. Now my configuration is saved. So if I'm now going to reload this router, have a look. Nothing will happen. Can you see that? It's coming with the R39. So this is the how you can configuration, save the configuration, copy running config to the startup config, right? Other ways you to save the configuration is what? You can put the command WR, the shortcut keyword. Write memory. right? So you can do this configuration as well to save the configuration. Either you can do the copy running config to the startup config, and either you can do the WR. Save the same thing. Let's go on a router 2 right now. I will save the configuration. I can save the configuration on router 2. I'll just put the WR, right? And same thing, I'll just go on the router 1. I'll do the copy running config to the startup config. That's done, right? So we have already saved the configuration. Now, can I send the traffic from here to here, guys? From PC1 to the PC2 right now. If you're gonna send the traffic, have a look. If I'm gonna say that, hey, let's follow the packet, right? I'll first ping my default gateway, right? So I'm sending the traffic from this PC to this default gateway in the same broadcast domain. I should be able to ping, right? But what happens if I'm gonna ping from here to here? Take example, if I'm gonna ping from here to here, right? Can you see that this is the ICMP packet that the PC has generated? And this ICMP, we have a source IP is a 1.1, which is this PC IP address, and destination will be 2.1. This is the ICMP type 8 packet. This is the encode request packet. My packet, if you see, auto capture play, this packet comes to the switch. Switch will look up the MAC and it will forward the packet to whom? Router. And what router is saying that it look up the routing table. Hey, do I know about the 2.1? Router said, hey, I don't know about the 2.1. So it will drop the packet. It's giving the reply, hey, I have no idea about the 2.1. I have no idea about the 2.1. Now the STP comes in the picture, so leave this guy STP. So normally in this case, what happened? Let me explain you again. So when the router 1, so the PC1 has generated the packet, say the hey, let's send the packet to the home 2.1. So the source IP is 1.1, destination IP is 2.1. So when this packet comes to router 1, what router will do that? The behavior of the router is what? It performs the destination lookup in the routing table. It performs the destination lookup in the routing table. And because of that reason, because of the destination lookup, it is also known as a destination-based routing. It is also known as a destination-based routing because of the destination lookup. Because of the destination lookup, it's known as a destination-based routing. So whenever the router receives the packet, what I told you that it look up in the routing table. Hey, do I know about the 2.1? Let me check. Do I know about the 2.1? Network not in the table. If the network not in the table, what should I do that? Simply drop the packet. If you don't have my number, what you will do that? You will simply drop the packet. So what is the solution now? Anyone can help me with the solution?
We have to
Multi-protocol.
Configure
define
the
route.
Define route. Which route I have to define, man?
Define the route to that towards the network going on the second router going towards the PC. I forget the IP address on that interface.
Take an example. So this is the Saurabh. Saurabh, तेरी age कितनी है?
ओहो, डेंजरस सवाल पूछ लिया.
बता दे. मतलब मेरी age का है क्या? So this is the Saurabh, and Saurabh ने जवाब देना ही नहीं. This is law, and take example. This is the Nasir, right? So Saurabh has a phone, right? So in the Saurabh phone, what happened? My number is present, law 123. So this is my number. Saurabh number is 456 and Nasir number is 789. And that's great, man, Nasir. Yeah, 45. So this is Saurabh also has a, you know, what we call, Saurabh doesn't have a Nasir number. And if I talk about law, in a law phone, I have a number of Saurabh, that is 456, and Nasir, I also have a Nasir number, that is a 789. Okay, so normally try to understand what happened. you tell me one thing. Can Saurabh make a call to the Nasib?
No, sir.
Abaya. Can Saurabh make a call to the law?
No, sir.
अबे कर लेगा ना, इसके पास तो फोन नंबर, he has a phone number, Saurabh has a
Acha.
phone number. He
Oh,
can make
okay,
a
okay,
call,
okay,
right?
sir. Okay, sir.
Now, so if he can make a call to the law, right? So, but Saurabh wants to make a call to the Nasib. So what he will do that? Saurabh first make a request to the, hey law, do you have a number of Nasib? So if the law has a number of Nasib, then what law will do that? Law will give the number of Nasib. Hey, Saurabh, this is the Nasib number 123. Now the Saurabh will put this number Nasib in the phone book 789, and then he can make a call to the Nasib. Same behavior of the router, we have seen that. If you don't have it out, you cannot make a call. If you don't have it out, you cannot forward the packet. If the Saurabh doesn't have a number, he cannot make a call to the Nasib. So what he has done, he made a request to the law, hey, can you please give me the number of the Nasib? And I have given the number to the Saurabh now. Now the Saurabh is making call to the Nasib. Exchanging the information. Exchanging the information is called what? Routing. Same way, in this topology that you can see that right now, in this topology that you can see that, the packet result, router 1, if you check the routing table right now, so IP route, I only have my own information. Router only maintain the own information. I only have a 10.1.12.0 and 190.161. Both are my directly connected. Can you see that? 0/1 and 0/0. Same thing if you go to the router number 2. How many routes router 2 is going to maintain? 3 routes. So IP route 12.23 and 2.0. How many routes is R3 is going to maintain? 2 only. 23 and 3. So router 1 doesn't have a route for this network. Router 1 doesn't have a route for this network. Router 1 doesn't have a route for this network. Same be router 2 doesn't have a route for this guy and doesn't have a route for this guy. Same way router 3 doesn't have a route for the 2.0. Router 3 doesn't have a route for the 12.0, and router 3 doesn't have a route for the 1.0. So if you don't have a route, what you have to do that? You need to bring this route into the routing table. You need to bring this route into the routing table, whatever the route you don't have. You need to bring this route in the routing table. How you will bring this route in the routing table? Same way router 2 doesn't have a route of this guy, and router 2 doesn't have a route of this one, router 2 doesn't have, and this one router 2 doesn't have. So you need to bring this route on the router number 2 as well. Same thing, router 3 doesn't have this route, router 3 doesn't have this route, and router 3 doesn't have this route. So you need to bring this route on the router 3 as well. But how? Who will help me over there?
Routing protocols.
Wow, that's great, Boozer. So the new guy comes in the picture. That's name is what? That's name is a routing, not a routing protocol. Routing is a mechanism. Routing is a mechanism that fetch the remote route into the local routing table. So I will say, hey, let me put this routing guy over here. So what routing guy will do that? He will say, hey, let me bring this route into my routing table. Let me bring this route into my routing table. Let me bring this route into my routing table. So routing is a mechanism that bring the route, fetch the route in the local routing table. Same way, when I move to the router 2 now, the router 2 also have routing. So what router 2 will do? He will fetch this route in the local routing table and this route in the local routing table. And then, so once we have done with this guy, same process will be R3 as well do that. But how you will fetch the route? So there is 2 ways to bring the route in the local routing table. One is called as a static, or we can call as a manual way. And second way we call as a dynamic. And dynamic, that Boozer gave me the answer, the routing protocol. IP routing is the routing, you can call it rename. The dynamic comes in the picture with the protocols we have. In a dynamic routing protocol, we have multiple flavors, right? We'll discuss that thing later on, not now. Focus, not as the important part right now. The most important part is the static. In a manual configuration static routing, what you have to do that? You need to do the box to box configuration. So you need to log into the each box, either the telnet or SSH or console. You have to go on the certain box. You have to go to the India box and define the route. So in the static routing, what happened? You need to manually, in the static route, what happened? Also called as a manual process. Define the route. So you have to log into the router number 1 and define the route which you don't have. Manually, you need to do that. So on the router number 1, I don't have which route. On the router 1, I don't have a 2. I don't have a 23. I don't have a 3. So I need to define, I need to go to this certain network. So we have a command for that one. So the first command to the static router is what? We have a IP root, the first keyword. IP means what? He's talking about the IPv4. Root means what? I want to go to this network. The syntax is what? Destination network. Then we have a subnet mask information. And then we have a, because if you don't give the subnet mask information, then how does the router will find the subnet? How does the router will find the network ID? And the next hop information we have. So you need to go on each and every router. What you have to do that? You need to go to the router number 1. Which route I don't have on the router number 1? Which route I don't have on the router number 1? On the
The
router
route
number
for
1,
2 and
I
3.
do not have a 23. I do not have a 2 and I do not have a 3.0. So I simply put the command IP root. The destination network is I don't have 23. And so if next hop, the next command is what? It's a next hop. Next hop means what? Next hop means neighbor IP address. So you tell me, according to the router number 2, router number 1, who will be the neighbor? 12 or 2?
10.1.12.2.
According to the router number 2, if I'm present on the router number 2, who will be the neighbor for this direction? This guy. For this direction, this guy. So depend
sir.
on the flow, your neighbor will be changed. So on the router number 1, what you do that? You need to put the 12.2. That's my next hop. Or this next hop or neighbor IP address remains same for all the route. Doesn't matter where you want to go that. So if you want to go from India to UK, I can give the same command. Same way I'm gonna give the 191.3.0 as well. I'm gonna go to the USA as well. 10.1.12.2. Same command we need to put in. The same next hop. So this configuration I'm gonna do on the router number 1 now. So just go on the router number 1 and configure this guy. Done. If you put the command do show IP route now, what I can figure out, hey, S means what? Static route. Don't worry about that. This thing will discuss later on, not now. But I have a route. Now I have a routing information in my routing table. Same thing, which route you don't have on the router number 2. So in the static route, always remember the route that you don't have in the routing table, the route that you don't have in the routing table, you need to define those routes. In a dynamic routing table or dynamic protocol, what happens simply, we advertise the directly connected route. So which I have, I'm gonna advertise it. In a static, it's opposite, which I don't have, I'm gonna call it. So on the router number 2, I don't have what? I don't have the 1 or 0. For the India LAN, and for this guy, my next hop will be still same, right? 12.1. For this direction, 23.3. Because I do not have a 3.0, right? R3 now we have IP route. I have a of course 1 or 0. So now R3 mean I'm going to define the India. So next hop will be 23.2. Of course, from this direction. So he will be the next hop, right? So if I'm going to do the 1 or 0, this will be the next hop. Same thing, I'm going to define the IP route 191.2.0. Right? For the R3, you want to go to the this guy, and of course this guy as well. And the last but not least, all done. R2. R3. S for static.
Just have one question. I'm sorry to disturb you. So,
Wait.
okay. If we look at if we are in router number 3, which is the 192.168.3.100. Okay, the next hop for the router is if I say the network 192.168.1.0, the next hop is not 12.1.12.0 or sorry .1, isn't it? Or
What I mentioned that your next hop always will be your neighbor IP address.
okay.
So from R3, who will be the neighbor for this direction? If you want to
It
go to
could
this network, this network, and this network, who will be the neighbor for R3?
23.2.
Perfect. Understood?
It's always compulsory service by default.
It's by default. If you want to change, you can change. Forget those things.
But
Right?
generally, but generally, it's the closest neighbor, right?
Closest generally. Otherwise, there is a problem.
That's
That's a
Thanks.
very advanced level problem right now. Yeah, if you, I know what your question. Can I define the 12.1 for this guy? You can define it, but there's a problem. So all done. Now you can set the traffic again, understand the concept. So now again, the router PC1 is going to send the packet to home. Source, I have a destination, I have. So when this packet comes to router number 1, right? What router 1 will do that? Router 1 will perform the lookup in the routing table. Hey, do I know about the 2.1? Yeah, I know about the 2.1 according to my routing table. I need to forward the packet to home 2. Okay, let's forward the packet. When the router number 2 receives the packet, what router 2 will do with that? Router says, hey, do I know about the 2? OMZ, I know about the 2. And according to my routing table, I need to forward the packet to home 1/0. So now he will forward the packet to the home 1/0. It will receive the packet to the switch. So it will look up the MAC table and it will forward the packet to home PC. So now we have a complete routing over here. If I'm going to send the packet now, 2.1. It's going to work. Working right? Well, -2 is not working. Same thing. If I'm going to send the traffic to whom? If I'm going to send the traffic to the 3.1, take example, that's my USA, India to the USA. So packet comes to router 1, router 1 look up the routing table. Hey, do I know about the 3.1? Yeah, according to my routing table, I need to forward the packet to the 2LR2. Oh, let's forward the packet to the 2LR2. When the router 2 will receive the packet, router say, hey, do I know about the 3? Right? Yeah, I know about the 3. So he will forward the packet to whom? R3. When R3 will receive the packet, R3 say that, hey, do I know about the 3? Yeah, according to my routing table, I need to forward the packet to whom? 0/1. 0/1 this interface. It will forward the packet to the switch and switch will forward the packet to the PC. We have all the routing we have. Always remember, whenever the router will receive the packet, it always perform the destination lookup. Because the default behavior of the router is what? It perform the destination routing. It perform the destination based routing. It always look up the destination. Can I do the lookup of the source? Yes, you can do the lookup of the source as well. That's called as a source based routing. So routing is 2 types. One is called as in a forwarding mechanism. One is called as a destination based routing, which is the default behavior. And another way is the source based routing, which is the non-default behavior. So normally it's a very rare scenario you use the source based routing. A very advanced level, high level things like a CCI level things are coming. So don't look up for those one. Only you need to discuss about the destination based routing, or in an interview, or very rarely this kind of question is coming, right? You know, can you help me out with the source based routing? Because even though most of the interview doesn't know about this thing. Yeah, of course, if the guy is very highly talented and highly experienced, then they can ask you about the source based routing. Otherwise, no. Everywhere you will see the destination based routing.
So basically in routing, whenever the one host wants to make a communication to the other end of the network, he always look the
Destination.
two things in his destination, which is the final host. In this specific case, we have a 168.3.1, right? Which is a US.
Right.
So this is a general common practice. So imagine if there are like 100 hosts in a network, and if, for example, how will it happen? So I mean, it will be happen.
Can you repeat that one again? I missed that.
Imagine if you have like 100 computers, 100 hosts in a network and devices.
Okay.
So I mean, it will the same rule will apply again.
Same rule, doesn't matter. How many hosts? All the hosts, right? If you remember, all the host is part from where? Same subnet, right? So it doesn't matter. तो मैं
How
ऐसे
will he
सोच रहा हूँ
figure?
कि हमारे पास 100 host को if I put all the 100 hosts over here in this 3.0 subnet, so all the other part of the 3.0 IP address, right? No
Okay.
issue.
So we'll just how will we be able to find out the
Switch will find out the MAC address.
No, I'm not talking about the background. I'm talking about the IP address.
Why you're gonna find does router maintain the IP address of the routing prefix or routing table? Routes maintain. Does router maintain IP address or routes?
No, it just mention his own IP address in the routing table. That's it. The router doesn't show the address choice actually of the all host addresses in the routing table.
It only show you the routes information, not the IP address information. You understood?
1 second. Let me have a look.
So your confusion is, you know what? You're saying that how does the router will find the IP address, right?
Yeah.
Why router will find the IP address? Router has a route. So one route is going to contain all the IP addresses.
Okay.
It's not gonna find the IP address. It's gonna contain the route information. Is it possible
You
that I
mean the
can see
table?
all the IP address on the router side for all the hosts?
Contain
No.
network ID, right?
Sorry.
Contain network ID,
Only
not
contain the
host.
network, only contain the network ID, not the host IP addresses.
Yes.
You just look at the network ID, that's it.
Yeah. Got it?
Right. Okay,
So
that's fine.
this is how you can define the static route, guys.
Starting routing.
Yeah.
Okay.
This is the one way that you can figure the static route.
I have a question.
Yes.
For
Vivek.
example, if you have in one location different VLANs, how do you?
Okay, I'm coming to the point, Buzel. Hold on. I'm not done with the static route, man. We have almost 3 days class of the static route. Hold on.
Okay,
We have
thank you.
lots of things to cover. So
All right.
second base, I'm just giving you the overview, man. Like, basic label of the stuff, CCNA label. We'll coming to the point. Is the default in the router one is the same broadcast domain? Yeah, it's of course same broadcast domain. So now we need to configure the next way to configure the static route. Second way we have is called the IP route, destination network, and serving mask information and exiting interface. There's a second way that you can convey the static route. So instead of putting the neighbor IP address, I'll put the exit interface. So what you can do that, first I'll remove the command. That's very important from all the router. So starting out with the next hop. Okay. And I'm just gonna use this one to just remove the command, nothing else. So I'll just put a no. To remove the static error, I say the no on the router one. And I'll configure router one now. Copy and paste. Oh, domain lookup. Same for the router one too. It takes some time. All has removed now. So I don't have a static router on the router 2 now. It's removed. Same thing on the router 3 now. No. 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 All run. So remove now. Wait. How the router 1, man? Still in the domain lookup. I'll just give some time, man. Is looking for the any website is there from the no keyword. That's a domain lookup is by default enabled. So to avoid this problem, you can put the no IP. I remember like when I was in the training of the CCNA, right? When I was learning the CCNA, I hate this thing. Like always I was doing the mistake of the no. And on that time I had no idea of the no IP domain lookup keyword. So yeah, that's problem. No IP domain lookup. Oh, it's not gonna work on the Cisco packet address. Sorry. So what you can do that, I'll simply configure the no over there. Remove the static route because we have to configure the different way now. It's gone, right? So another way what we have over there is instead of the next hop, we can configure like a what exit interface. So I'll just remove the next hop now. So from the router 1, what will the exit interface 0/1? So if you go this side 2.0, 23.0 and 3.0, the 0/1 will be the exit interface. On the router number 2 now, man, on the router number 2, if you want to go to the 191.161.0, so 0/0 will be the exit interface. So on the router number 2, if you want to go to this side, this will be the exit. And if you're going to this side 3.0, this will be the exit 0/1. Same way. we have a what on the R3? If you go to the this side 2.0, between 12.0 and 1.0, this interface will be the exit interface. All done, man. Copy and paste. Done. Again, guys, hold on. I'm not done. So I'm just giving you a basic overview of the static dot. We haven't covered to the, we are gonna do the debug and many things. We'll see that. I'll just showing you the how you can deploy the static dot in how many ways you have. R2 has done now, and R3. Now you can check the routing table, man. Do show IP route. I have my routing table. Right? So understand the concept, same behavior now. So if there are two, one will receive the packet for the 2.1, 3.1s, understand the concept. Right? What router one will do that? It will look up the routing table. Hey, do I know about the 3.1? According to my routing table, hey man, I know about the 3.1. You can see that? I need to forward the packet onto this interface, 0/1. Once the packet comes to the 0/1, it will automatically comes to the router number 2 now. When the router number 2 will receive the packet, he said, hey, do I know about the 3.0? Yeah, I know about the 3.0. So whenever the packet comes to me, I just process the packet on this particular interface. When I'm going to process the packet on this particular interface, what happened? It comes to the automatically R3 now. When R3 will receive the packet, what R3 will do that, hey, I know about the 3.0. Yeah, man, I know about the 3.0. I need to process the packet on the 0/1. So now he will forward the packet to the 0/1 interface, and my communication is going to work. No issue. Okay, man, there is some issue, it looks like. But where is the issue? 2.1. Two dot one is working fine. 3.1 is not working fine. So there will be might issue on the PC end. 3.1. 3.1 is correct IP configuration. That's good, man. Can I ping my default gateway from the PC? Yeah. Let me send the packet again. Because from India to the UK, ping is working. How about the 3.1 is not working? Let's ping the 3.100, the default gateway of the R3. Oh, wow. No, it's not working. Okay, now I'm getting the reply, man. So yeah, take some time. 3.1 is working. So everything is working now. So this is the second ways, right, that you can configure the static route, right? The third ways you have right? The third page that you have, it's called as a IP route, destination network, subnet mask information, and exit interface plus next hop, the combination of the first two. And I'm pretty sure you cannot do this level of advance on the Cisco packet tracer. I'll try it 1 minute. If I'm not, so this will be the task for you guys. Yeah, I knew that. It's error. You cannot. So this is the task that what you have to do that, right? This configuration. So of course you need to do this task, this one. So you need to do the lab. So of course you will get the task now in the routing, and you can do this lab from your end, and you need to put the message in the group once you have done. Okay, and now you may have a question, hey Law, if you couldn't do in the Cisco packet, how can I do in the Cisco packet itself? So what you have to do, you need to create the same lab on the GNS3 or EVNG. Okay, so if you have a EVNG, do the lab on the EVNG. If you have a Cisco packet server, do the lab on the Cisco packet. Do the lab on the GNS3. So anyway, same topology you can get over here as well. Not a big deal. So on the GNS3, if you don't have a PC, you can make a router as a PC. I just shown you the command, no IP routing, and you can make this router as a PC. You can do that. Okay. Anyone has any question, guys? If you want, I can help you to roll the configuration. Plus next hop.
What is the difference between those three configurations?
Okay, that's hold on. I'm not done. So first do the lab.
Alright.
I'll explain you that. Whatever I'm going to do the lab, everything has a region, man. Don't worry about that. So this is the configuration that you can do that. So I'll show you the command line on the router number 1 as well. So take example, I'll say that IP route. I know this route is not present, doesn't matter, static route, that's a beauty. If its route is not present, still you can give the route in the routing table now. Do show IP route. So this is the exit interface. And next up, I'm adding this routing in my routing table. So you need to do this lab, man, and then you need to put the message in the group. I'm damn serious about the lab now. Anyone has a questions regarding the static route? A basic fundamental, not the detail level.
All the three configuration has been in a chat, right? Into the
You
window.
want this notepad file?
No, I mean to say you have put everything to the. It will be in the drive, right?
I'll better do one thing. I'll put this notepad on the drive, right?
Yeah, this is the third way of.
The name of the static route day 1.
Okay, great. But this is the third way, right? Of doing
The third way that I give you out. 3
Sorry?
way we have. So you need to do the lab of all the 3 ways, man.
No, but the third way you have done, you have put the configuration, right?
I have put the configuration, you can see. Even I have shown you the configuration as well, how to configure it on the for the
No,
one. And this is the configuration.
This is the third way.
You just need to copy and paste, man, nothing else. But yeah, I know it will take some time. Maybe the 2 hours it will take, 3 hours it will take, and maybe sometimes it's not gonna be.
Which-
Don't worry.
The next
No,
copy
why
is
should-
the
why
same,
should-
right? The next copy, the check the next hop, the same router
The
one
next
also.
hop will say, oh, I'm so sorry, man. Yeah, it's not like that. It should be 12.1 for the 100. It should be 23. And this should be 23. Thanks. Good catch. And interface, of course, interface will be changed according to the topology. So if you're gonna use the different topology, your interface will be different. But yeah, apart from everything is same. Questions?
No question.
No questions.
Start.
So I'll
There will
put
be
this
questions.
notepad file. Okay, the name of
No.
day one routing. Let me save it. I really have no space in my program map. PC name.
I will call you after 10 minutes once the class is finished.
Yeah, man. Sure. Starting it route. Day one. Okay, guys. So I'll catch you tomorrow. Please do this lab if you're not gonna do
Hello?
the lab. Okay.
Hello?
So you will get a surprise from me. Yeah, go ahead. Anyone?
Actually, not, it's not regarding the routing. Actually, last week I missed the Ether channel classes. Yesterday
Yeah.
only I watched the video actually.
Okay.
I have one doubt on this one. You told Ether channel is between two switches, right?
Mhm.
If between three switches you mentioned as VPC.
You need to do the VPC then in that case.
Yeah. What if, for example, three switches, 4 line in the one switches, 2 and 2 in other switches. What I can split the channel group in switch one into 2? Is it possible?
You
Is-
mentioned the channel group is one side and channel group is one side. Yeah, that's possible. Yes.
Yeah, that's what I'm asking because you
Yeah.
said it's a VPC. What if
But in
instead
that
of
case,
I'm combining 4,
in
I
that
can.
in that case that you have a one block put.
Okay. No. For I'm just asking. I can create 2 channel group in switch one.
You can.
Yeah, that's what I asked. Yeah.
But make sure that you have a block put in that case. So there is no need, there's no sense to do the port channeling over there.
Yeah,
I
that's
have a
correct. But
question.
His question
how
is
come black port? I didn't understand. Can you draw it and then explain it?
switch 2 you have and
Yes,
like
correct.
this. So he said that I'll do the one port channel over here and one port
Correct.
channel over here, port channel 2.
Correct.
So of course now my topology will be something like this way, right? So I have a one port channel over here and I have one port channel over here, right? So take
That's
example, that's connected to the switch 2 and that's connected to the switch 3, right? That's my logical interrupt. So of course, span tree is going to run on the port channel, right? So take example, what happened? If this is the root bridge, right? Then what happened? So this link, either any of the link will go in the RP and any of the link go in the blocking, right?
So if it is block, how come it will make the connection? I mean,
so
in
because
logic.
you are running the span tree on the port channel now, right?
Correct.
So one of the port, hold on. So
no, if it is, I mean, blocking.
Hold on. So
GPS signal lost.
Signal. So you will be the root bridge in that case. So this will be, take example, here's a root bridge. So this will be the DP, this will be the RP.
Actually, there is no link between switch 2 and 3.
You will not have a blocking, of course. So this will go in the DP and this will RP. That's fine. Yeah, there will be no blocking.
Yeah, it will be working good, right?
Yeah, you
that's
can.
what
Yeah,
I
you can.
had
Yeah, you can.
doubt.
Yeah, you can do that.
Yeah. Thank you, bro.
I have a question. I have a question not related to the class, about the previous class. Okay, even in
Go ahead.
what is the number 67 and number 68?
I don't think so. I love to give this answer, man. Please, you need to watch the video then.
Yeah, the previous video, yeah, in the DHCP
You
video.
haven't watched the video, right?
No, I have watched the video, but I didn't watch the second one. The first one, yes. The second one I watched today.
Please,
Uh,
you have to watch the video. 67, 68 is the port number. 67 and 68 is a port number. 68 is a client port number, 67 is a server port number.
Okay, in a DHCP
Yeah, so
environment.
DHCP works on the UDP protocol number, and they have a UDP port number, which is 67, 68.
Okay, that's fine. And how about the relay agent? Relay agent is obsolete or still existing?
Still exists. That's a beauty of the DHCP protocol, the relay agent.
Okay, can you just like a precise definition of the relay agent? Because I listened to this video but couldn't understand very well. If you like
So,
it for
okay, so basically what relay agent is gonna do that. Relay agent is just gonna convert your unicast packet into the broadcast. So sorry, convert your broadcast packet into the unicast so that the user will get the IP address from the different broadcast domain. Relay agent is the feature of the DHCP. Okay, that helps you to convert your broadcast packet to the unicast so that
Right.
you will get the IP address from the different broadcast domain where the server is present.
Different broadcast domains where the server is.
Yeah, server is
And
relied, right?
yeah, unicast means as a single customer. I mean, obviously,
Not
at the
single,
host.
not single customer. Normally the packet is a broadcast, right? Discord packet. So
Yeah,
that's used
what I'm trying to
convert
say.
unicast.
I think leave that recording on because
That's fine.